Hello friends, I am Parthabatim Chakraborty from Department of Geology, University of Delhi. Today in this module we will be discussing about aeolian environment. Once you go through this module, you will be able to know what are the different processes that is operative in aeolian environment. You will be able to understand what will be the character of sediments of aeolian environment, what will be the stratification style, what are the different kinds of bed forms and how the different bed forms that create that kind of stratification style. You will also be able to comprehend that how we will be recognizing the product of aeolian environment in the ancient rock record. And that record of aeolian environment in the ancient rock, that how it will help us in identifying the the relative water table condition at that time, the relative climatic condition at that time, that how that helps us in the interpretation of a basinal scenario where the aeolian activity was operative. So, once we are now sure that what we will be discussing in this module, let us go to the classroom so that we can go into the detail of this topic. So, friends, what is aeolian environment? As we have partially discussed, I again reiterate that aeolian environment is that environment where the sediments are carried, transported and laid down by means of wind. So, that is what we call the aeolian environment. Now, essentially what happens, that where we get the major activity of the wind, it can be in a hot desert, it can be in a glacial outwash zone, it can be in a beach environment or it can be in a cold desert. In all these environments I can have the prevalent action of wind. Now, ideally when I talk about a desertic condition, what is a desertic condition? Where the rainfall is very low, that commonly people believe it is less than 25 centimeter. If there is rainfall, then that is what is a desertic condition. And a desert, essentially it is a equilibrium surface where neither we get a net deposition not a net erosion. So, what we will get, the major process in a desert, that is the transportation. And this transportation essentially is recorded in the different kind of bed form, different kind of stratification style, and that help us in interpreting the product of aeolian system. Aeolian sediments, they are naturally very clean and they are very homogeneous. Air cannot carry very big size of sediments. We have never seen that the air is carrying boulder. Have you ever seen? Never. Air can carry a very, because it is a very light density material which cannot hold a very big size of the high specific gravity grain. So, coarser grains are ruled out. The finer grains, they are commonly blown away. So, what remains is the medium size of the grain, that is the sand grains, and that homogeneous sand grains, they basically is the product of the aeolian system, and which is very clean and homogeneous. So, a very specific character of identifying a aeolian product is a very well sorted sand. Now, coming on to the different kind of products of aeolian system. Now, air is also a fluid as water. So, most of the bed forms and the stratification style, there should not, I should not expect much difference between a water led sediment and a air led sediment, because both are fluid. But there is a fundamental difference between the two. Unlike water, air will have a high, very high width boundary layer, and the capability of air to leave the grain is not as high as that of water. So, these two fundamental difference from water that cause the aeolian bed form slightly different from that of subaqueous bed form. But in both the cases, whether it is a subaquatic or it is a aeolian, we get current ripple. And as you know what is a current ripple? Current ripple is a asymmetric ripple. And we know in a ripple you have a stoss side, you have a lee side, and if the stoss and lee side, these two are not same, then I call it a asymmetric ripple or a current ripple, because stoss side is long and lee side is short. Stoss side is low gradient, lee side is of higher gradient, almost at angle of repose. Then you call it a current ripple. In case of aeolian system, what happens, that the current ripples are there, but they are amplitudes become much less than the subaqueous current ripple. So, a Eolian ripple is different from a current ripple of the subaqueous system by its lower amplitude, and it will always have a higher wavelength. So, if I have a higher wavelength and the lower amplitude, then the net result will be it will have a high ripple index, and that is a character of the Eolian ripple, that you will have a high ripple index. Now, coming on to the different kind of bed forms that we get in the Eolian system, we have the bed forms of different scale. It may be ripple, it may be dune, it may be draw. Now, what is a ripple? Ripple is the smallest scale, which can be from a millimeter to 1 centimeter, that will be its wavelength, and it will be recording the maximum speed of its migration. So, I may get even a ripple, Eolian ripple, that may migrate about 1 kilometer in a year. Now, we come to the dune. Dunes, they are of 10 to 100 meter, that will be their dimension in terms of wavelength, and they will be recording a migration, that is the 10 to 100 meter, that will be the migration of the dune. Whereas the draw, that will be 500 meter to 5 kilometer, that is the kind of the dimension of a draw, and they will record the minimum amount of migration in a year. So, the slowest is the draw, which is slowest in the migration, but the largest in the dimension. The dune is the intermediate, and ripple is the fastest but the smallest in the dimension. So, now we will discuss in a little bit detail about the Eolian bed forms. How are the Eolian ripples? Eolian ripples are commonly known as the impact ripples or the ballistic ripples. Why? Because it is basically formed by the impact of the saltating grains of sand that move in the transportation of the Eolian system, and that basically is the reason for formation of the ripples in the Eolian system. Now, these ripples, as I have already discussed, they will have a low amplitude and a high wavelength. The amplitude, that will be about 0.1 to 1 millimeter, and the wavelength, that will be a few centimeter. So, ripple index, that will vary from 8 to 50, and that is the kind of the ripple index I expect in the Eolian. If we draw a diagram, then you will further understand that what is really called by the ripple, then the dune and the draw, how they really differ. Now, you can see that this diagram clearly reflects that what we talk about the ripple, dune and the draw. 3 different scales of bed form. What I have discussed, that the ripples, they will be essentially, it is in the centimeter scale. This one is in the meter scale, and this one is tens to hundreds of meter scale. So, that is the variation in the scale of bed form that we call in the Eolian system the ripple, dune and the draw. Now, depending on that, what I have said, that the amplitude of these ripples, they are subdued with respect to the subaqueous ripples. Now, why this amplitude is subdued? Because it is the lesser lifting capability of the air. Now, air has a lesser lifting capability, and that will cause the lesser amplitude of the Eolian bed form. But one thing what we get, that all these bed forms, that is the ripples, it often becomes the sinuous in the plan, and you will get always the accumulation of coarser grains on the crest line of these ripples. So, that is a very typical character of the Eolian ripples, that the concentration of the coarser grains along the crest line. Now, depending on the relative geometry, what is the relative geometry? All these things depend upon the geometry and the direction of the wind, the velocity of wind and the supply of sediment. Depending on all these parameters, the Eolian bed forms, they assume the different kind of geometry. Broadly, the Eolian bed form, we divide it into number 1, that is the transverse bed form, and longitudinal bed form. Now, what is a transverse bed form? When the crest line, it is at a high angle nearly normal to the direction of the wind, that we call the transverse bed form. It will have a very significant single slip phase, and that we call the transverse bed form. We get a slip phase, so the slip phase through which the sediment avalanches. Now, this geometry we can also have sometimes the crest line, they are crescentic. Now, if I have a crescentic crest line, then we call it this kind of geometry, that the crescentic, which has two wings on the two sides, we call it the crescentic bed form, that what is called the Barkhan. Where does this Barkhan form? Overall, where the sediment supply is low. But this formation of two wings, that basically indicates that through these two wings the sediment supply was larger than the middle part of the bed form, and that basically causes the formation of the carp crested or crescentic large scale bed form in the Aeolian system, what we call the Barkhan. If we have the sinuous bed form, sometimes the bed form that becomes the sinuous bed form. The sinuous bed form, they now commonly form where the sediment supply is reasonably high or plenty sediment supply, then you get the sinuous bed form. But because the air is not very steady in its direction of movement, and the air often varies in this direction of movement, so what happens, the bed form crest often gets bifurcated and then reunite. So, forking of the bed form crest, that is very common in a Aeolian bed form because of the variation in the direction of the air movement. So, there is another kind of bed form that we get in the Aeolian system, which we call the parabolic bed form, which is just opposite to that of Barkhan. And the other major bed form what we get, that is what is called the longitudinal bed form. Now, what is a longitudinal bed form? That the bed form crest that will be more or less parallel to the wind direction, but it will always have a two slip phase. That is that I have a longitudinal bed form. If the crest line of longitudinal bed form is that, and the wind is flowing something like this, it may not be exactly following the crest line of the longitudinal bed form, but it can deviate about 25 to 30 degree the wind flowing direction, and that will cause a slip phase on this side because of the movement of this and the movement of that will create a slip phase on this side. So, what we expect? That we expect a bed form that will have the slip phase on both sides of it. There will be both sides there will be slip phase, and that is why when this bed form, the cross stratification of the longitudinal bed form I will get, then I will be getting a bimodal pattern of cross stratification. So, what will happen? That when there is a wind flow this, then you get a cross stratification like this, and then when wind flows that way, then you get a cross stratification like this. So, they will crisscross one another and you get a development of the longitudinal bed form. Essentially what happens, that the small scale bed form ripples, they migrate and they accrete it. So, the vertical accretion that becomes a dominant process later than the lateral migration. So, we must be clear that the bed form migration that can be both way. If it is a lateral migration, that is the active migration of a bed form, that when there is a Strauss erosion and Lee deposition, that we call, suppose there is a bed form, I just draw that this is a bed form. So, you have a Strauss erosion and Lee deposition, Strauss erosion, Lee deposition. So, then the bed form which was originally at this position, now it has migrated to this position. So, that is what is called the active lateral migration by the erosion and deposition. But what is happening here? Here it is happening that you are getting the vertical aggradation, vertical stacking rather than the march of. So, it is growing in size, and in the term of growing in size there is a lateral migration of course, but that growing in size because of the vertical accretion of the layers one above another. Now, we also have the start dune. Start dune is that where there is a 3 slip phase. So, you have 3 slip phases, they are joined together, then you call it the, so the multiple directions of the wind flow that cause the different kind of geometry of them. Now, once I discuss this, all these geometries of these bed forms, let me come into that what is the stratification style that we get in a Aeolian system. Two different stratification styles that specifically I want to discuss with you people. One, what we call the subcritically climbing translatant strata, and the second one, that is the grain flow and grain fall, grain flow and grain fall. Now, subcritically climbing translatant strata, that is the product that you will see in the figure also, I am also drawing that very low angle stratifications that you will get in a very well sorted sandstone, very low angle stratification, and very rarely you will get some 1-2 the ripple laminations, but it is very difficult to identify unless your eye is very set in the system, and but it will show that there are very small cross stratification of ripple lamination. Sometimes you will get the concentration of relatively coarser grains at the top of this strata. This is a typical product of the subcritically climbing translatant strata. What really is the meaning of subcritical climbing? I just want take a minute to describe you that what really means the subcritical climbing. You know that it, as I have really discussed, that the Aeolian system, it is an equilibrium system with neither net deposition nor net erosion. Then if you want to have some structure and the some product of Aeolian system preserved, then how you will preserve it is if nothing you are allowing to deposit. So, any deposit which will be preserved in the rock record of the Aeolian system, it has to climb, and that climbing cause the climbing translatant strata. Now, this climbing can be three different ways, just I discuss a little bit. A climbing can be less than the Stoss angle, a climbing can be following the Stoss angle, a climbing can be more than the Stoss angle. If the climbing is less than the Stoss angle, then we call it subcritical climbing. When the climbing is along the Stoss angle, you call it the critical climbing, and when the climbing is more than the Stoss angle, then you call it a supercritical climbing. Supercritical. In case of Aeolian system, what we get, the climbing at a very low angle, that is less than the Stoss angle, and that is why when you get the strata, you get a very low gradient strata, and that we call the subcritically climbing translatant strata. We then come on to the grain flow and grain fall, which is commonly we find because of the migration of the Aeolian large scale dune bed form. You will see that in the figure that is given in the text, but also I take a privilege to draw it and explain you. This is the pattern of a grain flow and grain fall. So, you can see there are some wedge shaped unit which is wedging downward, and the in between this portion that will be wedging upward. So, you have some wedging downward and some wedging upward. The wedging downward unit that we call the grain flow strata, and wedging upward unit, that is the intermediate between the two grain flow, that we call the grain fall unit. The grain flow unit is the product of active migration of the dune bed form, whereas the grain fall unit is the product of the suspension settlement from the air in between the two migration event. So, suppose I have a Aeolian dune, and for a time this small scale bed form, that is the ripples that is migrating through the Stoss surface of the Aeolian dune, and over a period of time this migration of the ripples that will carry sediment and that will accumulate sediment on the crest of this large bed form, and at one point it will come that it will exceed the angle of repose, and then it will avalanche through the lee phase of it. When it avalanche, then it creates a kind of cross strata which is wedging downward, and then internally you will see that it basically the process that is operative in a grain grain flow deposit, that is the grain flow process. And as you know, in a grain flow process the reverse grading is the criteria. So, I will expect a reverse grading within it, But once this avalanche takes place, then before the next avalanche there is a time when this migration is taking place, but the angle of repose is not crossed. During that time the suspension settlement from the air that will cause the formation of the air grain fall. This grain fall, because it is a suspension settlement, so I will expect a normal grading here, because it is a suspension. So, you have a grain flow and grain fall. Grain flow wedging downward, grain fall wedging upward. Grain flow internally reverse graded, grain fall internally normal graded, and they are repeated succession that basically cause a product of the dune migration in the Aeolian system is a typical character of a Aeolian dune migration, that we get the grain fall and the grain flow. Now, the other kind of product that we get in a Aeolian system, that is number 1, the addition ripple. When the addition ripple forms, when the surface is wet and the sand grains they get sticked onto the wet surface of a Aeolian system, and when the surface will be wet, when the water table is very shallow, and that is why the surface is wet, and that allow the loose sand to be sticked into it. That kind of system we call it the addition ripples that is formed. Sometimes what happens in Aeolian system, because the Aeolian sand that is very loose and non-sticky, if there is a rain, the sprinkling of water through the rain, that will cause the coagulation of sand grains within the desertic system, and that kind of coagulation of sand grains during the availability of the water during rain, that product what we refer to as the wort. This is the product of the coagulation of the sand. Now, overall when we see the Aeolian product, we will see that there are the different scales of stratification. The larger scale of the stratification, that is basically the product of the sand sea, what we call the arc, ERG, arc. What is the arc? Arc is a huge product of the sand, what we call the sand sea, where there are bed forms of different dimension, they superimpose on one another and thus form a compound kind of situation. And then if we take the kind of stratification in a Aeolian system, I can have some large scale stratification, then within that you may get some stratification, within that also you may get some other order of stratification. So, that is how we get, and then you get another kind of stratification. So, there are different orders of stratification. You can see this is one order, this is one order, then this is one order, this is internally within that. So, if I name this is 1, this is 2, then I call it 3, then I call it 4, this one. So, all these are the different orders of stratification superimposed on one another. Why these different orders of stratification that get superimposed? Because of the superimposition of bed forms of different dimension. The dry is superimposed by dune, dune is superimposed by ripple, and all has its own product, and they basically combine together to form the different orders of stratification. So, friends, we have now discussed the Aeolian environment and all the different kinds of bed forms, stratification, sediment character, and all these things we have discussed now. So, let us summarize that what we have discussed. Aeolian sediments is one of the most well sorted sediment, and we know that the major process operative, that is the saltation, and that creates the Aeolian sediment, that one of the most clean sediment and the more well sorted in character. We also have discussed, and you know that the unidirectional bed forms, that is the current ripples, they are very prevalent in the Aeolian condition, but they are always smaller in amplitude compared to the subaqueous ripples. We have also discussed that depending on the wind energy and the supply of sediment, how the different kind of bed forms they vary in their geometry and character, particularly there are crestal trend, there are bifurcation and all these things. We have also discussed that what will be the stratification style that of the Eolian bed form, that when we get the grain flow, the grain fall, the translatant strata, and what we call the wart and the addition ripples. We have discussed that when the water table is low and the surface is dry, then what kind of bed form I will expect, and when the surface is very close to the water table and it becomes wet, then how the addition ripples they becomes the major component of the Eolian system. Finally, what we have discussed is that what will be the stratification style of a complete Eolian arc. That is the sand sea of a Eolian system with a compound character of superimposition of different scales of bed form one above another. And when they migrate, that what kind of stratification style it will create because of the superimposition of the different kinds of bed forms. So, all these things together that basically talk about that what are the fundamentals of Eolian system which help us in the identification of the products of Eolian environment in the rock record. I believe that you enjoyed this module and you will be further referred to the literature on this, which will further enhance your knowledge on the product of the Eolian environment. Thank you.